Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Lukman Hakim Zaini. My metric number is S52336. So today I will present about my project on industrial bioprocess engineering and biomass potential nexus toward high value product recovery. This project is supervised by TS Dr. Shahrul bin Ismail and Dr. Muhammad Taufik bin Muhammad. This is the presentation outlines. Introduction. The oil palm trees is a multi-purpose crop that benefits the socio-cultural activities of the inhabitants of the area in which it grows. Malaysia is the world's second largest palm oil producer. According to the Star Online, Malaysia crude palm oil (CPO) export are predicted to rise moderately, with CPO production reaching 19.6 million metric tons in 2021, up from 19.14 million metric tons last year. Problem statements. Only 10% of the palm oil that are beneficial for the oil. The other 90% of the palm oil is considered as waste. Palm oil waste has been a huge problem towards palm oil industry. Palm oil meal effluent, POME, and empty fruit branch EFB are the most dominant byproduct from the oil extraction process. Poor waste management can lead to environmental pollution. For example, land pollution can be caused by oil spills that are generated by failing to recover the remnant oil in the EFB. This oil will absorb into the soil, thus affecting the soil nutrient. Aim and objectives. Aim. To investigate the potential of biomass recovery from palm oil plantation byproduct to another useful product. Objectives. To determine the probability of converting EFB from palm oil as a fertilizer, to evaluate the effectiveness of the liquid organic fertilizer from EFB waste on growth of spinach, to investigate the potential of EFB as a high-value recovery product. Scopes of study. Converting EFB into high-value fertilizer, gathering information on the properties of EFB-based fertilizer, utilizing EFB to its full potential. Significance of study. This research will ensure that the optimal way of recovering palm oil meal waste (EFB) by converting it into another usable product. Aside from that, this research can serve as a model for other palm oil mills to follow in terms of appropriately managing waste and not harming the environment. The effectiveness of the EFB waste fertilizer will be determined on spinach plant. Spinach plant was chosen in the study because leafy vegetables like spinach plant is very sensitive towards other substances. Besides that, it only takes 40 days for the spinach plant to fully germinate. Hence, it will grow to its mature size and it will be ready to be observed and analyzed. This is literature review. Methodology. First is selection of materials, which is EFB, spinach polybag, cattle urine, commercial fertilizer, compost soils, bioactivator, and molasses. Next is preparation of sample, which contain preparation of formulation A, B, and C, which is shown on figure 2, and plantation of spinach plant using different formulation of liquid organic fertilizer, which is shown on figure 3. After 40 days of germination, determination of pH temperature and moisture plant content on the spinach plant, determination of phytomorphology parameter for spinach plant, determination of NPK content in soil by using Moonbase RS485, which is shown on figure 4. This is Gantt chart of PITA1 and 2. Expected result. Composition consists of formulation A, EFB plus molasses plus bioactivator and cattle urine will become the most effective fertilizer. Formulation A tends to be higher in phytomorphology characteristic and soil parameter of spinach plant than the other formulation. Phytomorphology characteristic contain plant height, stem diameter, and leaf shape. For soil parameter, it contains pH, temperature, and moisture content. For macronutrient, it contains nitrogen, phosphorus, and potassium. For conclusion, the oil palm EFB waste can act as the main material in the organic fertilizer production and support toward the reduction of agro-industrial waste in Malaysia. The effectiveness of the organic fertilizer from EFB waste will be analyzed based on phytomorphology characteristics, soil analysis, and macronutrient detection. Formulation A is expected to be the best formulation based on the composition used that will promote the plant growth rate of the spinach plant. This is the selected reference. Thank you.